back to Rod's Radios. We're looking at a Murphy A168M. This is from around 1951 and it's a radio which was part of 3 other models that I got in a bundle well over a year ago, and at the time I took one look at it and said I'm never going to do anything with this, and I just left it aside. But now I've decided to take a second look at it to see if there's anything worth recovering. It's in pretty shabby condition, as you can see. The varnish is all cracked and crackled. There's lumps out of it here and there. The grille, well, that can be painted, that's not too bad. One of the knobs doesn't match the rest. The dial on the front glass is wobbling in there, it's shaking around, but that's not too bad because it's in one piece and all the print on the top side looks in good condition. None of the letters are missing from it. At the top of the cabinet is showing signs of where there was probably water falling down on it at some stage, because the veneer has come away from the top here and it's all cracked and discolored and bubbled. But that might be repairable. Let's have a look around the back and see what's actually inside. Well, the back looks even worse than the front. It is covered in rust, dirt, verdigris, spiders' webs, bits and pieces of spider themselves. The mains lead has disappeared. There's just this little stub here. There's a lot of rust and dirt on it. Funny enough, these are the dial bulbs, believe it or not, which were meant to shine up in that direction to illuminate the dial on the top. And it's a radio I'm not familiar with at all, because the valves in this radio are octal base valves. They're 8-pin valves with a little glass bulb to locate them in a certain position. And this valve I've never seen before, because I've never worked on valve radios with huge valves like this. This must be the audio output valve. This here is, I think, the rectifier. There's a fine big transformer in it, but I immediately noticed that the fusible spring has opened automatically, obviously due to an overload at some stage. And there's a little notice down here, and it says, to reset, heat fuse, apply heat only, never use solder. And there's another spider. Wonder where he came from. He's dead. So I'm not holding out much hope for this. Normally I wouldn't go near a radio like this because there's no FM on it at all. So the only AM available in the country at the moment is pretty limited, and the odd station from the UK. So on a practical term, it's not a lot of use. However, I'm strangely attracted to the challenge because it's going to be such a hard one to do. It may not work out at all. Certainly if the valves are gone, I probably won't be able to get them. They're nigh on impossible. The speaker is looking in pretty shabby condition, although maybe it's just rust. The cone might be okay, feels okay. So I'm thinking twice about whether I'll even attack this at all. But let me have a think about it, and I might take the chassis out and see if I can get some sort of sound out of it. If I can, I'll take it on as a challenge. If not, or if things look bad underneath as well, I may just leave it. Let's see what happens. Here's the underside of the chassis, and it looks like there has been a little bit of work done on this. There's a capacitor that's been replaced at some stage. The mains lead, it looks like it's being bypassed because there's no connections onto what I would assume is the on-off switch down here. So maybe the mains lead was just brought straight into the radio, and maybe a switch up here, or just plugged in and out as needed. A lot of these capacitors would have to be replaced. This. A couple of others around there. But other than that, it still looks as though it's in one piece. So I'm going to go ahead and see if I can get some sound out of this. This is the audio output transformer, which is slung underneath the chassis, a little bit unusual. But then this is an unusual radio. This radio was originally made for the Irish market, it would seem, Murphy Radio Ireland Limited. And I'm assuming it is a long wave, medium wave, and maybe shortwave. Possibly is what these little trimmers and coils at this in the RF stage are meant for. The loudspeaker from the speaker itself is plugged in at the back here, so that'll be handy if I do take the chassis out. I can plug in an external speaker while I'm testing it. So maybe we'll go ahead and see how far we get before I decide whether to go ahead or not. One other possibility is, of course, to fit a Bluetooth module inside the set and use it as well as a radio in its limited form, AM, as a Bluetooth speaker. So let's see. With the chassis out of the cabinet, I connected the mains up via the dim bulb up here, and everything came on as required, with the dim bulb coming on initially, then fading away and then coming back as the radio started to draw current. So it looked as though it was safe to switch on to full whack, which I did. And with the voltage up close to 220 and the radio set for 220, lo and behold, the radio lit up as far as the bulbs were concerned, and the valves started to glow. And if we just zoom out here, you can see the chassis out. It still looks pretty distressed looking. But lo and behold, when I turned up the volume and tuned in, some sign of life. We're tuned into one of the local stations here, the only one that's on long wave, in fact. And I hope you can hear some sort of voice in the background. Now, as you turn up the volume, you'll hear it distorts badly. So there's something definitely wrong there. I hope it's not the output valve, because if it is, we're bunched. So the next thing was to have a look at some of the voltages, which I did, and I've taken a note of some of them here. And you can see here the HT, the first HT came in at 235. It should be up around 285. HT2 185 should be around 255. HT3 146 should be 195. So all the HT voltages are down, and maybe this is what's causing the problem. And when you look at the cathode voltage on the output valve, it comes in at 12.3 volts, and according to the service manual, it should be around 6. Likewise, the anode voltage comes in around 170, should be up at 230. So the next thing is to have a look at some of the capacitors on the chassis, particularly the electrolytics around the power supply and some of the wax capacitors, to see if that makes any difference to the distortion and perhaps the level of sound volume as well. So, one step at a time. Before I switched on this radio at all to test it, I had soldered back the thermal cutout contacts that you can see here on the transformer. Now, there was very little solder left on the contacts anyway. And when I switched it on, after a few minutes, this contact sprung open. And it wasn't that the contacts were overheating. There was no solder left on the contacts at all anyway. But lo and behold, the radio continued to work. So whoever was working on this before, as well as bypassing the contacts on the on-off switch, also bypassed the contacts on the thermal cutout. Naughty, naughty. And over here, secondly, here's another odd thing. You can see the nylon thread hanging out of one of the IF transformers, and it turned out that the core in the IF transformer wasn't screwing into the threads of the former itself, so they'd obviously gone loose, and this arrangement whereby a loop of nylon thread was threaded underneath and back up underneath the core and used to pull up and down the core to tune in the IF as part of the alignment. So that was an odd thing. However, it's still working in a fashion, and I'm tempted to continue with this project just to see where it goes. Here's the main electrolytic capacitor. It's a 16 and 32 microfarad. And if you look at the date stamp on it, I wasn't too far off, November 1951. So let's test it and see how it works out. The first one is the 16 microfarad section. Let's see what that looks like. 17.12, that's not bad. Let's try the other one. This one then would be the 32 microfarad section. .34 microfarad, that's not bad. This capacitor is going straight back. The third HT smoothing capacitor is supposed to be an 8 microfarad. And if we check it out, let's see how it measures. It's slung underneath the chassis, separate to the other two. And there we are, 8.8 microfarads. Pretty good. Don't forget, this radio is 70 years old now. And the ESR on this capacitor is very low as well, which is good, 0.65 ohms. Likewise, the main capacitor also had very low ESR in a similar value. So these are going to stay. Let's move on to some of the other parts. These are the components I checked when I started to do the recapping. As I mentioned before, the HD1 capacitor, this one here, turned out to be perfect. The second HT, this one here, the 32 microfarad, again, absolutely spot on. And the third HT one, which was slung underneath, again, that was in perfect condition, so they were all replaced. However, when I looked at some of the other ones, I found some problems. The cathode bypass for the output valve here, 50 microfarad, was about twice its normal value, as was the cathode bypass for the previous valve, which is this one here, C20, again about twice its normal value. Now, both of those were in the same can, and I'll show you later how I restuffed the can to preserve some of the originality of the design. The other capacitors which proved to be faulty were this one, and this is the most important one because this isolates the DC from the previous valve to the output stage. You would normally have HT up here, and you certainly don't need HT down here on the grid of the output valve, but this one was leaking so badly that obviously the output valve was being overdriven by a massive amount, which I think contributed to, first of all, the distortion, and secondly to the current draw resulting in the lower HT. So that was replaced as well, as was this one up here. This is part of the tone circuit, and again it was very leaky, but not surprising because it was an old paper capacitor. And another one over here, I think it was this one here, C22, that was also very leaky. So these red capacitors all replaced, the green ones left in being. These are the capacitors I replaced. The three on the left-hand side, paper wax capacitors, were all extremely leaky, so they had to go. The grey one on the right would have been replaced somewhere in the history of this radio, but it was completely the wrong value. It was 4 times over the specified original capacitor, so that had to go. And the ones you can't see here are the 2 electrolytics which were in the common container, and I'll show you how I restuffed them. First of all, I peeled back the metal edge on the top edge of the can and removed the contents, and they were pretty messy and gooey. I got rid of the main part of the capacitor, cleaned out the container and retained the cap for further use. Then I drilled out the cap with tiny little holes to allow these 2 new capacitors be inserted into the bottom of them. And you can see how small these new capacitors are compared to what was in there previously. Then I wired the capacitors together, brought the leads up through the holes I'd drilled in the top cap and soldered them onto the original lugs. And then the common negative lead I extended out the back of the capacitor can through a further hole that I drilled in the base. With the recapping done, you can see the dual cathode capacitor where I stuffed 2 new capacitors into the original container, and it looks okay. One of the things I also noticed, I made a mistake earlier on, the on-off switch is actually part of the tone control here, so the mains lead actually comes into the correct setting there. What threw me was there is the remnants of an on-off switch on the volume control, which isn't in use. So obviously somewhere in its history the volume control was replaced, but the part that was put in also contained a switch as well, which isn't in use in this case. So what have we got after all that? I think it sounds pretty impressive now.
That takes a lot of politically correct boxes. It won't work, and we need regulation.
The sound has come up. It's a lot clearer, no distortion. It's extremely sensitive, which surprised me for a radio of this age. But what it does mean is I'm encouraged to move a little bit more with this one. The next thing I think is to do a little bit of alignment on it, although it's extremely sensitive and it seems to be picking up on medium wave some of the stations from the UK, which is quite good. So, next step, alignment. I've started the alignment and the service sheet tells you to inject an IF signal of 470 kilohertz, which I've set up here. And I put it down as low as possible. At the moment it's 10 millivolts, but it's also going through a by 10 times probe. So that should be about 1 millivolt, which is a pretty tiny signal. And of course it's a modulated signal. And I've just put a 600 hertz tone through this and a modulation depth of 30%. And we press the output button and it sends the signal off to the receiver. And it's injected in here. Hopefully you can see it. I put a capacitor between the probe and the grid of the first valve here at this point here. So the signal's been injected in here, and up here we have the two IF transformers, L13 and 14, and over here 15 and 16. And for this alignment, it's just a matter of adjusting the cores in the two IF transformers, this one, and it has a core at the top and underneath a core at the bottom. So it was a pretty easy adjustment, because all that has to be done is to adjust it so that the scope trace shows the maximum signal as you adjust the cores, the top, the bottom, the top, the bottom. And another way of monitoring the signal is also by connecting the AVO meter on the AC lowest voltage range across the loudspeaker. Now you don't hear any tone here because I've connected the dummy load in, but if I switch over to speaker, you can hear the sine wave tone of 600 hertz being injected. And it was pretty straightforward. The alignment was very little off. I had to do very little adjustment, but I'll show you what happens when you adjust one of the coils as an example. So here we are on L, I think it's L15. So I adjust it and it goes down, and I go back in the other direction and it peaks, and I continue to adjust it and it goes down the other side. So I just come back to the maximum setting, which is about there on the scope. And likewise, if I look on the meter here, am I at maximum? Yeah, more or less. And there we are. And the same is done for each of the cores, so that the IF adjustment is now complete. And now I can go on and adjust the RF settings, which basically align the stations where they should be on the dial. I'm at the beginning of the RF alignment, and because the chassis is out of the cabinet, they've conveniently put markings on the drum around the tuning capacitor here. Don't know whether you can see it, but there's numbers listed around here in a circle and a marker pip at this point here. And they start off by telling you to put the long wave switch in action, turn up the volume. I have the dummy load switched in at the moment so you can't hear it, and set the pointer here at number 62, which I've done. Then you inject a signal into the aerial socket at 176.5 kilohertz, which we have here. And of course this is modulated so we can hear a tone, and it's modulated at 30%. And the next thing is we come over here. But just to hear how it sounds, I'll switch on the speaker here. And we do have a tone, so it must be fairly close. the dummy load's been switched in again, just so it doesn't annoy us. And it tells us to align this little trimmer, which is buried down here. This is L11 on the circuit diagram. So I'll put my little trimmer tool into that. And we go over to the avometer, which is connected across the loudspeaker, and start adjusting this. No, it's not in that direction anyway. So we go up in the other direction. And yeah, this one was a good bit off. My trimmer has slipped out of the core, so I'll try and locate it again. Okay, and keep going in that direction. No, I've gone past the peak. So there's our peak. Good. On to the next stage. The next instruction tells you to set the drum dial up to 167 on the scale, and this time feed in a 300 kilohertz signal again into the aerial. And now the adjustments this time, they tell you, are these two trimmers here. These are capacitor trimmers, that one and this one down here. So let's see what happens on the meter when I do that. It's a little bit tricky with one hand on the camera and one hand tuning in, but we'll see what happens. No, not that direction anyway. Oh yeah. Oh yeah, that came up. There we have a peak. And then the other one, which I think is the aerial trimmer, and that's buried down here. And I'm going to have to get a little spanner to adjust this, because this is a different adjustment altogether. One moment, please. Yeah, the adjustments on these trimmers are done by way of a nut. So all I can do is use a box spanner on it. Not very sophisticated, but we'll see what happens as we... Yeah, that's coming up. Woo. Oh yeah. Past the peak. And go back again to about there. And there we have our peak on the long wave band completed. The medium wave band is similarly aligned, except obviously you switch over to medium wave. And this time it tells you that on the drum you should set it up for 156 on the scale, which I have done. And now you feed in a signal of 1364 kilohertz. And this time you align the two middle trimmers, this one here and the middle one buried down here. So we'll start with this one here. There's very little signal coming out of it. I left the speaker switched on, and there's virtually no reading on the meter, although I can hear a tone, so we must be somewhat out of alignment. And here we go. Dummy load switched in so it doesn't annoy us. Okay. So back to the trimmer again. No, too far. There's the peak on that one. And now we go down to the middle trimmer with the box spanner. No, past the peak. And there's our peak there. So that's the first part of the medium wave done. Let's see what else we need to do. No, that's it. The shortwave RF alignment was done in a similar fashion, with the drum set as before, the same setting as for medium wave, except this time the signal goes in at a much higher frequency. It's 15.230 megahertz. And like the other two adjustments, which I won't bore you with, it was the final two trimmers, this one here, which was extremely finely adjusted, and this one down here, which was a lot more broader. So the full RF and IF alignment is now complete. With the alignment done, the radio sounds really great. I mean, it still looks like an awful rust bucket in a terrible state, but I might clean it up somewhat from how it is at the moment. But let's have a listen to it in the meantime. This is on shortwave, and all I have is a piece of wire hanging out the back onto the aerial socket. And it's the middle of the day here, so I'm surprised to hear anything at all. Let's try medium wave. That's a weak radio 4 coming in from the UK. Nothing much else on medium wave. And then long wave. That's radio 4 again.
Unbelievable. An 11-year-old boy saves his granddad.
And that's our local station here on long wave. So we have a result of sorts. It still looks terrible, but I'm going to start cleaning up a little bit. I'm not going to do an awful lot to it because I might end up doing more damage. But there are a few things I need to do. For instance, the mains cable needs to be assessed. And what I'm going to do is put a 3-core cable onto this and wire it in correctly, earthing the earth wire onto the chassis here. And I'm going to do something about this thermal switch, which obviously isn't in circuit at the moment. I think I'll put a 500 milliamp fuse in line with that as a safety device instead. I can't solder it because there's nothing to solder, and it says not to use normal solder on it, so I don't know what they had in mind there. However, we are making progress now at this stage, so I'm still going to go ahead with it because it's nearly there really. So the next thing is to attack the cabinet and see if I can enliven it up a little bit and make it look a little bit better. It looks very shabby down there, as you can see. But I'll bring it outside into the garden and start stripping down the outside. I've taken the fixtures and fittings out of the cabinet, as you can see here. We're out in the garden, and I'm going to strip down the varnish from the outside of the cabinet with the aid of this non-toxic paint stripper, and we'll see how this turns out. I'm probably going to try and re-veneer this, although it's a bit ambitious for me because I'm not a woodworker, but we'll have a go anyway. And here you can see where I've painted on the stripper. There was quite a thick layer of varnish and wood dye on this cabinet, and it took 3 sessions of painting it on and scraping off the gunk and goo that came off before I got it back to the original laminate or veneer. This is the result of stripping the cabinet, and it's made me change my mind about trying to veneer it. With all the curves on the front and my inadequacy of woodworking, I think what I have on this cabinet already is going to have to do. So I'm going to stick with what I have. It doesn't look too bad. In the meantime, I've glued down the top bits that were loose at the top pieces of veneer, and filled in the gaps that were there. Now it's not perfect, but it's going to have to do. After this, I painted on a coating of wood dye, and this colour is called American Walnut. And here you can see the first coat that I applied, and then the second coat. Now I applied a third coat after this, but unfortunately it started to rain in the garden, so I had to bring it into the garage, and it rained and it rained. So I'm not going to show you that, but it just ended up a little bit darker than the second coat. So now it's time to apply a coat of varnish to this to give it a kind of a silk finish. The cabinet has now been sprayed and sanded with 3 coats of a silk finish varnish, and it's looking pretty good. So now all that needs to be done to the cabinet is to remount the fixtures and fittings inside. In the meantime, back to the chassis. If you remember, the chassis in this set was extremely rusty, showing signs of wear and tear. So I decided to paint it with rust converter, and the rust converter is a white liquid that you paint on the surface and it turns blue immediately, and as it dries it solidifies into a black, hard wearing protective layer on the chassis. And here you can see the results. Likewise, the loudspeaker in this set was all rusty on one side. Here it is before, and here it is after. You may wonder why I had screws sticking out of the back of the chassis in order to connect the speakers and aerial. And that's because the sockets on this radio were made to take what were called wander plugs. These are the wander plugs that were connected to the speaker. And as you can see, they're all rusted, decayed and bent. So I decided to upgrade the sockets on the back to more modern sockets. And here you see I've fitted what are called 2mm sockets. And they will suit nicely because they take low profile plugs rather than the bigger 4mm banana plugs and sockets that I could have used. So this has proved a good solution, and I think it'll work out okay. To make the radio as safe as possible, I've fitted a new mains lead. Now this is a 3-core lead, and you'll see here how the earth lead from the mains lead is now wired onto the chassis itself for safety reasons, so nobody gets a shock. And on top of that, I have fitted a fuse now in line with the mains lead, which you can see here, and I've strapped it onto the top of the transformer. So inside here is a 300 milliamp fuse, and if you look over here you'll see that the radio currently draws just a little over 200 milliamps. So hopefully this will keep it an awful lot safer than the thermal fuse that was on this radio before, even though it was bypassed from whoever was working on the set. So a little bit of safety has now been built into this set. To make this more useful rather than just being an AM radio, I had planned to put in a Bluetooth module, and here it is. This is wired into the phono input on the radio, and it takes its power supply through this blue lead from the 6.3 volt AC line, and a convenient point was taken off one of the indicator bulbs. So 6.3 volts come in here, it gets rectified by a little bridge rectifier here to DC, about 7-8 volts. Then it gets fed down here to a 7805 voltage regulator, the output of which is at 5 volts. This 5 volts then gets fed to this little block here, which is a 5 volt to 5 volt DC isolator. At which point it then gets fed into the actual module, the Bluetooth module itself, which is this little board here. And you can see here the little zigzag aerial that picks up the Bluetooth signal. There's 2 LEDs on this, the red one just to, it's linked into the DC power supply just to show that the power is actually there. And then an actual blue LED here, which blinks initially when you switch it on. And as soon as you pair it up with whatever you want to play through it, it stays steady until you start playing something. So let's hear what it sounds like. I have my iPod here with some music on it. Hopefully it is okay to play this, but let's see what it sounds like. So pretty good sound coming out of this for what was just going to be an AM radio. It gives it a lot more versatility, and of course you can control the volume and whatever you want to play through the iPod itself. So it makes this radio an awful lot more useful. So now with everything more or less done, it's time to put the chassis back into the cabinet. Just before I put the chassis back into the cabinet, I found a couple of other things that needed done. There were 2 more capacitors that needed replacing and 2 resistors that had gone way out of value in the AGC line. So here we are, the chassis is back in, it's looking pretty spruce, and let's have a closer look. So the cabinet turned out pretty well. I'm happy with the darker look than the original. The front grille was sprayed gold again, so that's looking pretty neat as well. The dial was all cleaned up, and particularly the reflector behind the dial, which was an unusual texture, and you can see the way the light comes through it. It gives a sort of an orange glow throughout, even though the bulbs are quite a distance below the display. The top, unfortunately, I wasn't able to perfectly fix, but it was the best I could do under the circumstances, so it's a little bit ropey still, but it's smooth. And down below, the other thing I wasn't able to do was to find a matching knob for the volume control to match the other three, but maybe I'll find one at some future stage. Side looks pretty well okay. So let's hear what it sounds like. I'll put it onto long. This is long wave, and we only get one station here in Ireland on long wave. It's our local RTE station.
Really, within the next 48 hours, it could be later today or it could be tomorrow. He'll be landed, presumably in Baldown Airport, and brought straight.
It's possible to get another station which is over in the UK, which is Radio 4 on long wave, but at this time of the day I'm not sure how it'll come in, but let's see. It's up on 1500 meters. Not so good. And likewise on medium wave, there's not going to be very much on medium wave, but we'll have a look and see. It's about 11 o'clock in the morning here. No, everything's pretty noisy. Let's try shortwave. Although I'd have my doubts about shortwave again.
Beijing.
And coming up in this hour, buy now, pay later has become a kind of new...
Shortwave from China. Not bad. Remember, this is being picked on just a piece of wire hanging out of the back of the receiver. The other thing you may notice is I've painted the dial indicator white, which makes it look a lot smarter. So the other thing, of course, was that I fitted a Bluetooth module into the radio. So let's hear how that would sound. And to do that, I have to select the gram setting, because, of course, the Bluetooth module is wired into that. And here on my iPod, I have what I hope is some royalty-free music. So let's hear what it sounds like. I like it. I like it a lot. So to finish up, for something that started as a possible no-hoper project, I'm reasonably happy with the outcome of this. So if you have been, thanks for watching.